is a pioneer institution which is granting research fund to the faculty members of affiliated colleges. But it is a mandatory point to attend research methodology workshop before applying for the research grants. And as a part of this ritual, we every year conduct research methodology workshop prior the notification for inviting the research grants by the faculty members. Sorry, 5 sessions are there for today's. That is up to 4:15. I will be beginning with research introduction to research methodology, and it is followed by Anurag Kurpad, designing and framing research proposal, followed by Rajesh Chennai, writing a research proposal, then biostatistics after the lunch, and ethical considerations by Professor N.K. Sudarshan, 3:15 to 4:15. These are the 5 sessions we will be conducting in this workshop. The first one is research methodology. In this particular workshop or in this particular session, we will be concentrating on what is research, what are the research objectives, research questions, variables, and hypotheses. After understanding all these particular specific headings of the research topic or research proposal, Anurag Kurpad will be discussing about the designing and framing of research proposals, and that will be continued by Rajesh Chennai regarding proposals for RGHS. Slide. Going into the topic, we will be concentrating on basic definitions. One is science. Science is evidence-based systemic methodology of understanding natural and social world by applying the knowledge. Isaac Asimov clearly defined it as verification of my thought with nature of the world. And broadest sense includes gathering of data, information, and facts for advancement of knowledge. In this case, what actually is, we gather the data, information, apply it, and interpret it for the purpose of advancement of knowledge. It is a scientific analysis way. Systemic investigation into and study of materials and sources to establish facts, reach new conclusions, because the conclusions again is a relative term, because sometimes the one conclusion which is drawn from the science may be changed after few more research. Investigation and experimentation aimed at discovery, revision of accepted theories or laws in the light of new facts, or practical application of such new revised theories or laws. Then in the broader sense of research, the broader sense includes gathering of data, information, and science. And you see what then in the research, there are two aspects. One is discovery, another is invention. Here, in this case, discovery means the process of finding information, a place or an object or a specialty, especially for the first time, or the thing that is found. For example, you see, it is already there. I discovered it. For example, the gravitational force is always there, but Isaac Newton identified it for the first time. This is called as discovery. For example, act of detecting something new or something old that had been unrecognized as meaningful. Earlier, it might have not been. Gravitational force has not been recognized as a meaningful thing. But once that apple falls, then Isaac Newton thought of or recognized it as a scientific fact. With reference to science and academic disciplines, discovery is the observation of new phenomena, new actions, or new events, and providing new reasoning to explain the knowledge gathered through such observations with previously acquired knowledge from abstract thought to everyday experience. Discovery may be based on earlier discoveries, collaborations, ideas. Some discoveries represent radical breakthrough in knowledge or technical. Discovery of penicillin. Penicillin was there existing, but Fleming first identified this particular material. It is not is in and neurotransmitters is there right from the life existence of life, and it has been identified by dates. So in such conditions, these discoveries are identification of or recognition of existing facts. Invention is something that has never been made before, or the process of creating something that has never been made before is a unique one. Like now a ECG machine, it is an invention, it is not discovery, it was not there, it was first time made. Similarly, the synthesis of a particular method, synthesis of a particular drug from a method is an invention. Similarly, composition of various drugs into a polypharmacy is again invention. Invention of insulin pen or a pump or rotahelers. These are all inventions. Are examples. Even Thomas Alva Edison invented, there are 326 equipments. Like that, invention is a new thing which is created. Then for research, what shall be our temperament? First one is open-mindedness, questioning attitude, scientific honesty, non-differentiating attitude. You see, these are the basic qualities, not only for the science, but it is for the human character also. Because if you don't have the open-mindedness, we will not be in a position to identify the specific inputs which we get through our experimentation. Therefore, we should be open-minded. Even if it is negative result, we should accept it. Similarly, questioning attitude. Without questioning, no research can be established. No research can be carried out. Similarly, scientific honesty is the most important thing, wherein plagiarism or corrections of the scientific results, manipulations, all these things shall be avoided in a scientific temperament or in any research. And non-differentiating, non-biased or non-differentiating attitude must be there so that you can come out with a realistic facts through your research. Then scientific way of research. What are the ways of research? One is key element, empirical approach. Always this empirical approach was there right from the ancient time. The empirical approach is a type of trial and error. Then observationals. You see, observations is again objective observation and subjective observations. People in ancient science or ancient researchers used to have objective, subjective observations. And after that, we evolved various parameters to measure the scientific subjective observation and convert them into the objective observations. Then putting a question or raising the question and getting the answer. Next is generation of the hypothesis and verification of the hypothesis through experiments, analysis, and then conclusion and replication. Without any replication, precise research results cannot be undertaken. Therefore, or any facts or any research, any aspect cannot be ascertained. Therefore, replications are very much essential in case of research. Characteristic of research. Research shall be relevant to the present condition. You see, I will tell you how the relevance shifts. It is again a relative term. In 1980s, American government has stopped funding for TB research because it was not relevant. The almost TB was vanished from the world. But after the advent of the AIDS, again now TB research has been, FDA or American government started funding TB research because of the advent of AIDS. So the relevance will be changed in accordance with the endemic conditions. Then our research should be focused one. I will, in the next forthcoming slides, I will tell you how a focused research is generated. Then our research should be interesting to the public and it should be always applicable. Then, though we have got several ideas, we have to think about the researchability of the research. Can we carry out any parameter to ascertain it, or it is simply a statement? If it is simply a statement which cannot be researchable, is again a myth, and people think that it is a blind belief. Now, practical versus research problem. You see, practical problem is the purpose, aim, and objective of your research shall be there. Those things will motivate, and after that motivation, we will have research questions. And after research questions, we will try to define it, and we design a research problem to get research answers to the research questions. Then we get the findings, we get research answer, and helps to solve the practical problem. It is like a positive cycle. It is not vicious cycle. It is a positive cycle to identify the various stages of research. Then write words in this. You see, whenever you want to write the research question, there shall be a right wordings. If you want to have any positivist question, it shall begin with what is and how big it is. If you want to interpret the results, if you want to interpret the concept, then how do, why do, should have been used. If you want to critically analyze it, why is it, why not it. Design and creations, how good is, how can we create. You see, because what happens is, I have seen as a research director, I have seen many research questions. The research questions are whether it is there or not, whether it is effective or not, whether it is useful or not. Like that, we start questioning, we design the questions. It shall not be like that. What type of question you are raising? Is it positivist question, interpretationist question, or critical question, design and creation question? On the basis of your way of research, you have to design the questions. Now, example of how to design a question. You see, now first I will tell you two examples to clarify this, how the focusing of the topic and how the research question shall be. Women's health is the broadest. It is a broadest topic. To narrow the topic, women and cancer. Focus topic, women smokers and breast cancer. You see how we started from women's health to smoking and breast cancer. Thereby, this is the focused topic. From the focused topic only, we can have a research question. Is cigarette smoking associated with breast cancer or risk? Similarly, eating disorders is the broadest, and teenagers and eating disorders are narrowed. Then focused is teen peer, that means teenagers pressure and teenager peer pressure and bulimia. Bulimia is a eating disorder wherein it carves for eating continuously. What role, if any, does peer pressure play in the development of bulimia? You see, now broader question, broader area we selected, narrowed it, then focused it, and from the focus, we started designing the research question. It shall be the way. Then research objectives. The research objective shall be a clear, concise, declarative statement which provides direction to investigate the variables under the study. It summarizes what is to be achieved by the study. researchers' objectives are specific accomplishments and researchers hope to achieve by the study. You see, in this case, I will tell you why this research objectives, you see, I have seen many dissertations and proposals where they will be writing 8 to 10 objectives. Objective is to prepare the extract, to analyze the extract. He is doing some protective activity or some genomic alteration due to the administration of a herbal product. Instead of making it, he will be writing it preparation of the extract, analysis of the extract, standardization of the extract, and then effective. All these things are not objective. Your objective is clear, that it is consigned and it is precise, that you will be testing the effectiveness of so-and-so drug on so-and-so disease or in so-and-so animal experiments. Like that, it shall be more precise. You don't write all the 15, what are you are conducting experiments, all those things are not your objectives. Your objective only single. If at all, if there is a need, you can divide objective into primary objective and secondary objective. For example, in case of bioequivalence and bioavailability studies, what we will be doing is, that is our primary bioavailability and bioequivalence study of so-and-so drug is our primary objective. To achieve this, secondary objective is we will be developing a new method for simultaneous estimation of these drugs in the serum. It is a secondary objective. Like that, only 1 or 2 objectives has to be designed in a research project. Then smart objectives of the specific. Your objective should be specific, which I was telling, and it should be measurable. And then the research, the measurable thing or research may be attainable, and it shall be realistic. You see, I'm telling you why I'm using the word realistic. If I think that there is a transparent metal, is it realistic? Transparent metal is not realistic, it is opaque. So that realistic shall be there, then it shall be time bound. No funding agency will be giving you infinite time for completion of the project. There is a time bound research design shall be there. Therefore, it shall be specific, measurable, attainable, realistic, and time bound. Then research variables. Research variables are qualities, properties, characteristics, behaviors, or attributes, etc. of an individual, a group, objective, situations, activities, etc. That changes are vary. Variables are manipulatable and measurables. Any research variable in this matter is a parameter of the study. The parameter may be dependent or independent parameters. You see, types of variables. We have got independent variable, dependent variable, extraneous variable, environmental variable, demographic variables. We shall discuss one by one now. Independent variable is the quality or property that can be manipulated by the researcher to cause an effect on the dependent variable. For example, these are called as experimental variables. In clinical condition, they are called as treatment variables. Here, if you give certain drugs, the dependent variable is altered. For example, if I talk about paracetamol, if paracetamol is an independent variable, whereas reduction of the elevated temperature is the dependent variable. So when there is a independent variable is altered, dependent variable is changed. This is what is the difference between the dependent and independent. Then dependent or variable is quality or property or behavior or outcome that researcher predicts that occurs in response to manipulation or experimentation or treatment or administration of the independent. They are also called as outcome variables. Example, oxygen administration to highly nervous patient by a face mask instead of nasal canal will cause less anxiety to the patient. You see, in this case, administration of face masks or nasal canal are the independent variables. Anxiety is the dependent variable. Okay. Oxygen administration, only method varies, but anxiety outcome is changed. Similarly, you see, bioavailability of the insoluble drugs can be enhanced by preparing the nanoparticulate formulation. Here, here in this case, bioavailability, nanoparticulate formulation is the independent variable. Altered bioavailability is the dependent variable. So when you change the formulation, that is, researcher change the experimental variable, the outcome variable changes. Outcome variable is dependent on the experimental variable. Similarly, I'm giving a few examples. A regular consumption of antioxidants prevent the oxidative stress induced organ damage. Organ damage is the outcome variable, whereas antioxidant administration is the dependent variable. Increasing the electronegativity, this is for the chemistry people if you are listening, increasing the electronegativity at the carbon 5 of the heterocyclic ring increases the adverse effect. You see, increasing electronegativity at the carbon 5 position of the barbiturate ring increases the adverse effect. Adverse effect is the outside. That is the outcome variable. Then we have got several number of such examples can be given. Then next is, after dependent and independent variable, next is extraneous variable. Extraneous variables exist in all types of research studies. They confuse or mix up the relationship between the variables and interfere with the rationale or causal relationship between the independent and dependent variables. The researcher must make attempt to identify the extraneous variables before a research study is initiated and thereby control the influence of extraneous variable on research study throughout the specific research design or through statistical manipulation. Is an example. A calm, quiet environment at bedtime at night will allow sound sleep to a patient in general ward. In the above example, the independent variable is calm and quiet environment will have an effect on dependent variable. Here, the calm and quiet is an environment is the extraneous variable. Similarly, lifestyle changes, non-pharmacological interventions and drug treatment is highly effective in maintaining the blood glucose level. In the above example, life changes and pharmacological interventions are extraneous variables having effect on the blood glucose level. Then environmental. They are composed of research setting where the research study is conducted. This variable are climate, family background, social background, institutional setup, community setup, educational setup, etc. You see, whenever we want to use a method for any research from the others, that is by giving the reference we use, we never say that we have used this. We say that it is adopted. Why, we have adopted that to our setup. It is adapted to our setup. Therefore, we have to adapt in accordance with the institutional setup. These areas are also type of extraneous variables. In descriptive or correlation research study, and where it is necessary to study the subject's behavior in natural setting, the researcher must make no attempt to control or alter the environmental variable, because we should conduct experiments in the realistic world, not in a controlled experiment. That may be controlled experiment is necessary for pilot or necessary for initiation of the research. But when you go for the broader sense of research, we have to conduct it in the natural condition. the dose of drugs, for example, the dose of drugs required to treat asthma in winter is more than the summer. Here, environmental variable plays, because during winter there is a asthmatic shocks will be more prevalent, and at that time you may have to require higher doses. This we call it as chronopharmacology. In Ayurveda, they call this as Rutucharya, Dinacharya. Education, and say example 2. Educational levels of patients, socio-economical status of patients influence the rational usage of antibiotics. I think in a rural setup, we might have seen people will be going to a pharmacist and asking for Vatanavide Kodi drug. The pharmacist will prescribe or dispense it without the prescription, because the uneducated people will be going to him for that. So this will be affecting, if that is the condition, it will affect. If the volunteers in clinical research are uneducated, they should be clearly monitored for the drug adherence and relevant and rational uses of drugs. Then demographic variables. They are the qualities, properties, or characteristics of the subject under study, and which are collected to describe the sample. These variables are also called as sample characteristics. The subject example for the particular demographic variable: age, gender, height, weight, build, movement, vision, hearing. All these things will be in one or the other condition affecting your research outcome. Therefore, there shall be a commonality of setup of this. But that's why we mention normally in research proposals, the people under the age of 40 and above, or we see childbearing age woman, because if it is affecting the childbearing property, childbearing woman, like that, we specify the demographic variable and then take up the work or initiate the research. Then hypothesis. They are predictions about the relationship among two or more variables or groups based on theory or previous research. It is being defined by Pettinger in 2003. Other person defined it as they are the assumptions or theories that a researcher makes and tests. He first assumes this may be like this. Then he design it and test it and then confirm it. Another researcher statement stated that hypothesis is a formal statement of the expected relationship among the variables. One more, Krellinger hypothesis defined it as hypothesis is a conjectural statement of the relationship between two or more variables. So there are several people defined it. Now I want to discuss on hypothesis, theory, and fact. First, we shall come to the hypothesis. A specific testable prediction about what is expected to happen in the study. And it makes a specific prediction about the specific set of circumstances. It is a speculative guess that has yet to be tested, is new and relatively untested. The hypothesis is the probability of error and corrections are in hypothesis. Probability of error high, probability of error is high, and even corrections is also high. When it comes to the theory, it is a well-established principle which predicts events in general terms. You see, first when a person discovered aspirin, he has discovered aspirin, he has invented aspirin, and he tested it on pain-killing effect of it. That was hypothesis. After repeated administration and repeated uses, aspirin reduces the pain is a theory. Arises from repeated observation and tests. Theory incorporates facts, laws, predictions, and tested hypotheses that are widely accepted. Extensively tested and is generally accepted. Then what is fact? Fact is much more higher confirmation of your theory. Is something which is assumed to be true. Once the theory has been confirmed and reconfirmed over and over again, we get to the point that it will be treated as a fact. doesn't mean that it is again absolute certainty. For example, one common feature of facts, theories, and hypotheses is in science is that they are all treated as fallible. That means alterable. The likelihood of error might be very greatly, but they are still regarded as something less than absolute truth. For example, when Isaac Newton identified that a light moves in the straight line, now light moves in curve also whenever there is Rutherford's golden file theory proves that. You see, so there is a change in the theory and as well as the facts also if it is retested and new facts are arose from the research. So hypothesis, theory, facts we know now. Now, what is the purpose of hypothesis? It gives direction to the study, what to do, defines the facts that are relevant or not relevant, suggest from a form of research design likely to be the most appropriate, provides the framework for organizing the conclusions and findings, limits the research to the, you see, this is most important. It limits the research to the specific area. It will not take a hypothesis, will not take away to the broader things. What is your hypothesis? Raise the question, get the answer. This is what is very much specific, offers explanation for the relationship between those variables that can be empirically tested, furnishes proof that researchers have sufficient background or knowledge to enable, because your hypothesis will be giving an evidence that you have got sufficient knowledge and background about this, structures the next phase of investigation, and therefore furnishes the continuity to the examination problem. Then hypothesis can estimate population characteristics, correlate variables, display differences among two or more population, show possible cause and effect. It helps in data prediction, data collection, and interpretation. What research design relate to each of these four functions? This is all same. Then how many types of hypothesis? Research hypothesis, null hypothesis, testable hypothesis. Research hypothesis is again divided into 6: simple hypothesis, complex hypothesis, directional hypothesis, non-directional hypothesis, causal hypothesis, and associative hypothesis. We shall see one by one. Simple hypothesis, it predicts that there exists relationship between the dependent and independent variable. That is, you see, example is there. 2 hourly position changing of a fully bedridden patient will prevent bed sore. In the above example, 2 hourly position changing is independent variable and the bed sore prevention is dependent variable. The statement shows that there exists a relationship between both the types of variables. Complex variable, it predicts that there exists relationship between 2 or more dependent and independent variables. Again, example, for a fully bedridden patient, 2 hourly position changing, 2 hourly back care, and high protein diet will build up body resistance, will promote blood circulation, and prevent bed sore. You see, there are 3 dependent variables and 3 independent variables. In the above example, 3 independent variables are 2 hourly position changing, 2 hourly back care, and high protein diet. Three dependent variables are promotion of blood circulation, building up body resistance, and prevention of bed sores. The above sentence predicts existence relation between all the 6. Then directional hypothesis. Directional hypothesis predicts the direction to the relationship between the dependent and independent variables. Example, high quality pharmacy education or any health education will lead to high quality practicing of pharmacy or nursing or professional practicing skills in the professionals. When the quality education is improved, practicing skills improves. This is what is the, and how that parameters you have to design. What are the improvement of the quality of education and what are the outcome you are expecting. If these quality factors are correctly assessed, correctly intervened, and the outcome will be same. This is how the direction is given. Then non-directional, it predicts the relationship between the independent and dependent variable, but not specific or direction of the relation. For example, student to teacher-student relationship influence the student's learning. See, there is no direction. For example, my teacher was a simplistic thinker, always used to give any complex problem, he used to give me a simplistic thinking. And when I stayed with him for 4 years, I learned the simplistic. But it is not directional. Everyone need not learn. Then causal, it predicts the cause and effect relationship. It in this depend and the dependent, and in this hypothesis predicts the effect of independent variable on the dependent variable. Example, the post-operative ambulatory care leads to prompt recovery. That is cause and effect relationship. I think this is also a type of simple hypothesis. Then associative hypothesis. It predicts associative relationship between the independent variable and the dependent variable. When there is a change in any of the variables, change also occurs in the other variable. Positive association, there is a possibility of positive association or negative association. Then it comes to the null hypothesis. This hypothesis also called as statistical hypothesis, because this type of hypothesis is used for statistical testing and statistical interpretation. The null hypothesis predicts that there is no relationship between the independent and dependent variables. You see, in Rajiv Gandhi University of Health Sciences, PG proposals and PhD proposals of homeopathy faculty, they specifically mention to ask the student to write both research hypothesis and null hypothesis. They write both and they test. When they write both, I feel it is more open-mindedness, because you are ready to accept the negative fact also, negative result, or you are ready to accept the positive results also. Because many times students will be thinking of always a positive result. And there, when you always think of the positive results, you will be thinking of manipulation. Your open-mindedness the scientific temper is lost. And that's why always we suggest the students to accept the negative results. There is one journal I was verifying in the list, that is negative results in pharmacology, is a journal of negative results in pharmacology. If you get negative results also, you publish it. It is like that. That means a negative or null hypothesis is also acceptable here. Either again is the same, simple hypothesis, complex hypothesis, and causal and null, same. So explanations are negative only. High intake of fluid does not cause tissue edema. In the above example, the independent variable, that is high fluid intake, does not have any causal relationship with the dependent variable. Smoking, drug abuse, alcoholism, tobacco use, etc. have no relationship in occurrence of malaria. Then associative increased dose of antibiotics will not reduce the body temperature. These are all negative things. Then in any research, we will be having the assumptions. After the objectives, research questions, hypothesis, we will be going for the assumptions. They are the statement of basic principles, facts that are established and are universally accepted as true on the basis of logic or reasoning without verification or proof, though they may not have been scientifically tested. Assumption is picked up by the researcher from various sources. These sources may be previous research studies, theories, clinical fields, etc. I always feel, as a researcher, assumption is the weakest link of your research chain. If you attack assumption and disprove it, your whole research is collapsed. So always I feel assumption is the weakest link of your research chain. research limitations. They are the restrictions within the research study which reduces the credibility or generalizability of the research finding. The limitations of research study are also called as weak points of the study also. It is necessary to recognize the limitation of research study which might influence the research results or the findings. Thank you. This is about the initiation of our workshop. Are there any one or few questions maybe entertained? If there are any questions, you can unmute yourself and please you can pose the questions on this. Have I heard clearly? Sir, have I heard clearly? Hello?
Yes,
Anyone
yes,
of you,
you are,
please?
sir. Yes, you are clear, sir.
Yes, sir. You are
The
clear,
screens
sir.
are shared. Someone is sending message that your screens are sharing. What about audibility? Sir, ask, unmute and ask questions, sir. Someone has raised a hand. Please unmute and ask, sir. Please unmute and ask. Hello? Hello? Sir, please unmute and ask, sir. Someone has raised Samsung SM. Or if you please, you can send the chart also. There are 19. Good morning. Sir, is there any question in the chart? There are 99 plus charts. Your audible is there, sir. Are there any? No, you are all there, senior lecturer, you are all there. I would like to know your questions, sir. If there are no questions, we can end this session and Anurag Kurpal will be taking the next session exactly at about 12. Another 2 minutes he will be taking. Okay. Thank you one and all. Be in the workshop. We will call the Anurag Kurpal. Anurag Kurpal sir bandarama.
Sir, I am on this. Sir, I am here.
Anurag Kurpal sir phone madam. So Anurag Kurpal sir is there.
Yes.
I think, sir, you can share your Anurag Kurpal sir, you can share your things, sir.
Sir, you have to allow sharing. Save it.
Sir, you unmuted, sir. Anurag Kurpal sir, you unmute your mic.
It is unmuted.
ಹೌದೈತಿ ಒಂದ್ ನಿಮಿಷ ಮೊದಲಲ್ಲಿ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಕ್ ಹೇಳ ಸರ್ 1 minute ಅನುಕೂಲ್ ಸರ್ ಈಸ್ ವಿಲ್ ಬಿ ಅನ್ಮ್ಯೂಟಿಂಗ್ ಯು ಪ್ಲೀಸ್ 1 minute. One minute.
Hello, can you hear me? Hello.
1 minute, sir. 1 minute, please. 1 minute.
Yes, sir. Yes, sir. Okay, sir. You can share the presentation, sir.
Sir, I think you can talk now, sir.
Yeah, can you hear me? Hello.
Sir, can you talk now?
Can you hear me? Hello.
Yes,
So
sir.
it is not audible here. Whether
Ah.
others are, is it audible for others?
Hello. Hello. I can hear you.
Sir, Professor Anurag Kurpat.
Yes.
Yeah. We can hear you. We can
Ah,
hear you.
Thank you, sir. Thank you.
No, brothers. 1 minute, sir. You are not audible to me. I don't know whether for others it is audible or not. ಕೇಳ್ತಾ ಇಲ್ಲಲ್ಲ ಅವ್ರು
ಅಲ್ಲ
ಮಾತಾಡೋದು.
ಇದು
audible,
ಡಾಕ್ಟರ್
sir.
ರಾಮಚಂದ್ರ ಶೆಟ್ರೆ, ಡಾಕ್ಟರ್ ಸುದರ್ಶನ್ ಹಿಯರ್. ನಿಮಗ್ ಕೇಳಿಸ್ದೇ ಹೋದ್ರೂ ಪರವಾಗಿಲ್ಲ, ನಮಗ್ ಕೇಳಿಸ್ತಾ ಇದೆ.
Hello. Namaskara. Yes. I've joined. Yes, I've shared my screen. All done. Okay. Bye.
Okay, sir. You can talk, sir.
Sir, can you talk?
Can you hear?
We shall
Can you hear me? Hello.
ಇಲ್ಲ, ಆಗ್ತಾ ಇಲ್ಲ. ಯಾಕೇನಾಯ್ತು ನೋಡು.
Yes, sir, it is audible.
Okay. But only for Dr. Shetty, sir, it is not audible.
ಕೇಳ್ತಾ ಇಲ್ಲಪ್ಪ.
Volume ಇದೆ, sir.
ವಾಲ್ಯೂಮ್ ಇದೆ, ಫುಲ್ ಇದೆ ವಾಲ್ಯೂಮ್. ನೋಡಿ ಸ್ಪೆಷಲ್ ಸೌಂಡ್ ಆಫ್ ಐತಲ್ಲ, ಆನ್ ಮಾಡು.
Sir, your PPT also visible, your slides also visible, your audible.
ಹೌದು, ಇದಾರೆ, ಅವ್ರು ಕಾಣ್ತಾ ಇದಾರೆ ನನಗೆ.
Can you
ಅವ್ರ
hear
ಧ್ವನಿ
me?
ಬರ್ತಾ ಇಲ್ಲ.
Open ಮಾಡ್ಕೊಡ್ಲಾ?
ಮಾಡ್ಕೊಡಿ, ಧ್ವನಿ ಬರ್ತಾ ಇಲ್ಲ ನಮಗೆ ಇಲ್ಲಿ. ಇನ್ನೊಬ್ರು ಯಾರಿಗಾರ ಆ ಕಡೆ ಹೊರಗಡೆ
ಕೇಳಿಸುತ್ತಿಲ್ಲ ಅದು.
ಅವ್ರೇನ ಮಾತಾಡಿದ್ರೆ ಇಲ್ಲೇ ಇಟ್ಬಿಡ್ತೀನಿ ಬೇಕಾರೆ ಅಲ್ವಾ? ಈ ಮೈಕ್ ನೆಗೆಟಿವ್ ಬರುತ್ತಲ್ಲ.
ಒಂದು ಸರ್ ಮಾಡ್ಕೊಡ್ತೀವಿ.
ಸರ್ ಅವ್ರ ನಂಬರ್ ಹೇಳ್ತೀನಿ ಸರ್.
ಅಲ್ಲ, ಐತ್ ನನ್ನ ಹತ್ರ ಇದೆ.
ನನ್ ಫೋನ್ ಹೋಗ್ತಾ ಇಲ್ಲ.
ಬರ್ತಾ ಇದೆ.
ಹೋಗ್ತಾ ಇಲ್ಲ ಸರ್.
Hello.
Sir, you are not audible. There is technical hiccup. That is the problem.
ಅವ್ರು ಬರ್ತಾ ಇದೆ, sir.
I can hear you, sir, 100%.
From yours.
ಮಾತಾಡಕ್ಕೆ.
Now you can speak, sir.
Hello.
Allah, sir, you speak in the laptop.
I am doing that, sir. I'm sitting in front of laptop.
No, ಅಲ್ಲಿ ಬರ್ತಾ ಇಲ್ಲ ಅವರು.
ಅದು ಇಲ್ಲಿ ಬರ್ತಾ ಇಲ್ಲ, ಅವು ಬರ್ತಾ ಇದೆ, ಮಾತಾಡೋದು.
Sir, what about you? People from YouTube, are they listening? ಕೇಳು.
Yeah, sir. We are listening, sir. We are listening.
1 minute, sir. I will ask others who have
audible,
joined.
sir. Clear.
Phone
ಬರ್ತಾ ಇದೆ.
ಹೇಳ್ಬೇಕಲ್ಲಮ್ಮ.
ಅವ್ರು ಕೇಳ್ತಿದ್ಯಲ್ಲ ಸರ್.
So you are sitting.
We are able to hear, sir.
Sir, go ahead, sir. Everything is fine.
That's what I am asking, sir.
We are listening.
Sir.
I can start, sir.
Perfect, sir. Perfect.
Okay. I'm just waiting for Dr. Shetty to give the go ahead.
You can start with sir.
Okay, sir. Thank you.
Everything is fine. You can start with sir.
Thank you all for being here.
Okay, sir.
And good afternoon. This talk is on.
Sir, you
how-
can begin with sir.
Yes, sir. Start it. This is a talk on how to design and frame.
Sir, you can begin, sir.
Sir, I've started.
So you can start posting. Thank you for being here. And good afternoon. This talk is on.
Hello, can you hear me?
Yes, sir, we can hear you clearly.
Okay. So this
It's
talk is
a
on designing and research.
ಬಟ್ ಜಾಯ್ನ್ ಆಗ್ಬೇಡಿ ಒಂದು ನಿಮಿಷ ಏಕೋ ಒಂದು ಅಟ್ಲೇ ಡಬಲ್ ಇದಾಗುತ್ತೆ
ನಾನು ದೂರ ಹೋಗ್ತೀನಿ ನೀವು ಆಮೇಲೆ ವಾಪಸ್ ಬರ್ತೀನಿ.
Recording in progress.
Okay, sir.
Okay, I'll start. So, as Dr. Shetty took you through in your previous lecture, very beautifully, he has defined what a hypothesis is and gave you examples. And really,
ಇಲ್ಲ ಅಂದ್ಮೇಲೆ ಅದು
hello, can you mute, please? So, there are two types of research, really. One that is driven by the hypothesis that you write, and the second is when you are beginning your research, it is called hypothesis creating research. So, when you start your research journey, you have to have some idea. And this idea could be because of your clinical practice or your research practice, or even you just coming from home to work, you have some observation. You see some gap, you see some problematic issue. So, really, what you want to do when you write your research grant is to define this problem and then talk about how you plan to address it. To address it, you have to first define a hypothesis. So, there are many ways to go about this. There are designs that you create in studies. The first design, which is the simplest design, is what we call a descriptive study. A descriptive study is where you say, I think there's a lot of some particular disease in my area. I would like to define how many people have this disease. I would like to define what their characteristics are, what their habits are. And I hope in doing this, I can come up with a hypothesis that says that because people do like this, they have more disease. That is what we call a hypothesis generating study. It is when you're starting out that is usually done. And usually these kind of studies are done at the master's level, MD level, where you have to do a short thesis and then people finish it off. It's a simple study. It can be done very quickly. The next study is what we call a physiological study. Physiological studies are where you are beginning now to look at the mechanism. You are looking at taking a blood sample from your patients or whoever you observed. You want to then look for specific markers and then relate those markers to the outcomes. So now you're putting some biomarkers between the exposures that you have measured versus the outcomes. You're looking at mechanistic biomarkers. This is called physiological studies. For those of you who are in pharmacy and in pharmaceutical approaches, for example, if you look at bioavailability, that becomes a physiological study where you're looking at giving you a certain molecule and seeing how much is absorbed. That is what it requires a little more money because you have to measure some biomarker. Next comes an analytical study. Analytical study is where you statistically work out mechanisms. So, for example, there are two ways to do this. One is called a case control study, and the other is called a cohort study. Now, these studies are good, but they are not perfect. What is really perfect is what we call the experimental study, which is a controlled randomized trial. So I'll go through each of these, and you'll see at the bottom, I put an arrow from left to right showing how the study rigor improves as you go from left to right. So these are the types of study. So let's start with the descriptive study. A descriptive study, as I told you, was you write a grant in which you very clearly must define who you're going to study, define which disease you're going to study, give some pilot observations that you may have made, that you see that in the last year, you've seen so many cases suddenly appearing, something like that. Then you have to define to the committee, how will you measure that disease? Because that should be a robust measurement. You can't just say, oh, I will just do some clinical observation. No, it has to be a very objective observation, no subjectivity. You must be able to describe for your committee in the grant how you'll describe this disease by seasonality or time when it occurs, how you'll describe it by geography in terms of rural versus urban, how you'll describe it by person, like male or female, or different age groups, and so on. So you can now see how you can develop this grant where you just made some observation that some disease seems to be occurring more. Then you begin to define it properly. You tell the committee how you'll measure it and how you look at it in different groups. So now suddenly a grant proposal is becoming obvious. Finally, remember that all committees may not believe that you are correct unless you can locate your findings in the context of what is known. So many times they will ask, okay, you're doing all this. How do you know this is true? Has it occurred elsewhere? Has anyone else looked for it? So you should be able to give what we call a external validity to your study by saying, well, so and so has found similar things, so therefore it could be possible. Finally, it helps if you can tell the committee that at the end of this, we will be able to formulate a hypothesis. So this is a hypothesis generating study. And when you do this, please go back to the previous lecture where Dr. Shetty nicely laid out for you all the different types of language that is used in a hypothesis. Please go and make your hypothesis based on what you are studying. So this is a so-called descriptive study. It is the simplest design. It is very easy to do. You can do it very quickly. It is not expensive as long as your biomarkers are not expensive. But remember, it is also the least attractive of study designs for funding. Typically, these kind of studies are expected to be done without real funding. It's usually done by what we call intramural funding within your department or college. So let me go to the more attractive designs for funding, which you should all think about. The one important one that you should think about is this analytical design, which is a so-called case control study or cohort study. Now, the case control study is where you will go and pick up patients who have a particular disease. And you'll pick up patients who are very similar to that patient with the disease, but without the disease. Do you understand? So now you're getting your cases and so supposing you got a man with diabetes who is about 60 years old, your control will be a man who's 60 years old from the same socioeconomic group, but without diabetes. So this is what we call the case control approach. And what you're saying is that you will go back in history with these patients and controls, cases and controls, to figure out what is it that was different in their habits, which could have led to risk for this disease. So you come up with an odds ratio or risk of that disease occurring with specific habits. So if you go back, I'm staying with the diabetes example, you go back in the history and you find that one person has a habit of eating refined rice, one group, versus the other group eats less refined rice, then you might come up with a conclusion that the risk of developing diabetes is more if you ate refined carbohydrates or rice. So this design is particularly nice because you can finish the study quickly. One of the problems you will have is that you have to write a grant that you will complete in 2 years or max 3 years. You have to recruit your patients. To do that fast, you need to have a hospital where you get lots of patients and lots of controls, or whatever. You have a community, or if you're doing public health, you have to think about how you will convince the committee that you have a practical design in front of you that allows you to recruit X number of patients and X number of controls, and how you will go back into a historical evaluation of their habits, or you will do genetics, or you'll do some biomarkers, and then you'll be able to very quickly finish the study. Equally, there's also a very robust design called a cohort study. Now, in the cohort study, you just take a bunch of people just randomly in a community and you follow them up and you wait to see who develops a particular disease. Again, let's stay with diabetes. You take a bunch of people and you follow them up and you see after a few years who among that cohort developed diabetes, who did not develop diabetes. And then you figure out, because at the beginning of the cohort recruitment, you would have taken a full history from them of their habits. You can figure out that the man who got or woman who got diabetes had this specific habit. You then can work out a risk factor. Now you can see that this, depending on the disease, can take a long time to do. It may take years or decades for people to develop a chronic disease. So a cohort study is not a great design to come to the committee with a proposal, because unless you have a disease that develops within a few months to maximum of a year, you don't want to follow up that cohort for too long. So another example of a cohort which probably stretches what you could do in a design is, for example, what we call a pregnancy cohort. You may recruit women who are in the 3rd month or 4th month of pregnancy, but then you have only a 5-month follow-up or 6 months before the child is born. So everything finishes in the cohort within 6 months to 1 year, which allows you to have your outcome, which is, for example, you may say, I want to recruit a cohort of women. I will measure their weight at when they were recruited, and then I will see them till they deliver, and I will look to see which woman had a low birth weight baby, and then I'll go back to see whether low birth weight babies were delivered in women who started out with a low birth weight, the low pregnancy weight. Can you see now how this cohort works, where you characterize them at the beginning when you recruited, they went on to have an outcome, and then you go back and look at their characteristics that you had measured at the beginning, and then you can figure out things. So cohort designs are very, very powerful, but remember, you've got to make your design in a way that allows you to finish your study. Otherwise, you'll never get funded. Now, I've spoken quite a lot, but remember this, that eventually when you write your grant, make sure in a case control study, which is an easy design, is the most common human study design that we see. It is that you will select your cases and controls very carefully. You will match them for age, you'll match them for sex, you'll match them for socioeconomic status, you match them for geography, urban versus urban, rural versus rural, like that. Next, you'll be able to measure, if you go back in history, what exposures they had. And finally, please get a good statistician who can interpret the data. For a cohort study, please define how you will select your subjects, how you will characterize them the moment you get them. How will you get that data? And then how will you'll go on with follow-ups and so on. Now, I've spoken a lot. The truth is, you don't need to remember anything I've said, because if you go onto Google and you type in this thing called STROBE, STROBE is the strengthening of the reporting of observational studies in epidemiology. It's an acronym. It is really a wonderful resource that is available online, which tells you exactly how you should define your grant. So if you go to the STROBE and go into that site, if you look on that list, they have what they call checklists, which makes it so easy for you to write your proposal, because you just have to make sure that everything on that checklist is there in your grant proposal. And you should mention that in your grant proposal, that you have followed the STROBE guidelines, and then even the reviewer feels confident that you know what you're talking about. So please, there is a checklist for cohort studies. Can you see this? Checklist for case control studies, checklist for cross-sectional descriptive studies. Just go down that and figure out, and you can take it in Word or PDF. It's so easy to use. Okay, so I just want to stop at this point by saying, forget everything I've said. But just remember and figure out everything I've said so far. Can you please mute yourself? Okay.
What is
Now,
a bubble?
hello, can you please mute? Okay. There are other types of studies called experimental studies, which I told you was the most robust
How you
design.
get attention by giving a bubble?
Madam, can you please mute yourself? Madam, can you please mute? Shubha Deshpande, can you please mute? Okay.
Something
So there
near the surface area?
what can I do now? Dr. Shetty, is there some way to mute these people?
It increases the surface area so that the respiration will have a proper fit. So only you give the bubble. That is what you are. Welcome main. Why do you give a bubble? That,
I have to stop here because this lady is not allowing me to speak. Okay, I
सर का
think
क्वेश्चन का आंसर नहीं किया एंगल क्या है शैम्फर का
I think from the IT side, they can mute all the participants. So
yeah, I think they should please mute everybody.
Schillingberg
This lady is not listening. I don't know what she's doing, but it is very disruptive. Okay, so let me go on. There are two types of studies, the experimental studies, which are the robust designs. Now, it's very tempting for you to be, if you're a clinician particularly, to say, what, every day I'm doing this experimental study. I am getting patients, I give them a drug, I follow them up, and I see if it works. So the problem is, then they'll say, yeah, so why don't I write a study saying, this is really disruptive. Can everyone please mute themselves? So they would just say, yeah, let me just take maybe 100 patients who come to me with hypertension, and let me just treat them. I'll have their blood pressure before, and I'll have their blood pressure after treatment, and then I'll compare before and after. And therefore, I can say that the treatment reduced the blood pressure. And let me write a paper saying that this drug at this dose is effective. Now, this is a very seductive way of doing research in the sense that's the old way it was done. But we began to realize that there are what we call confounding factors in every observation, which may alter your results. So, for example, if you are testing the effect of a drug on hypertension and the price of salt went up, such that people just ate less salt because the price went up, you may find that blood pressure goes down because salt intake went down, but you think it's because your drug was there. Now, I'm not saying this is a true effect. All I'm trying to give you is an example that this is how research gets confounded. As a result, research designs began to have what they call a control group. A control group was a group that was not given the intervention. And so you had a non-intervention group called the control, an intervention group, and this information on what they're doing. This is for ethics reasons you have to give because you have to get informed consent. Many times, patients, when they come out of the clinic, they say, oh, let's exchange what we have. You know, you give me yours, I'll give you yours. This is what we call leakage, where the control and the experimental group, they leak their interventions. As a result, what sometimes we do is what we call a cluster randomized trial, meaning we will do one intervention in only one hospital, and in another hospital, geographically separated, we do the control. So there's no question of leakage occurring. So there are two types of randomized control trial. One is the so-called cluster randomized trial, and the second is called the individual randomized trial. Most of the drug trials we get to are individual randomized trials, but many times when you do public health interventions, they tend to be cluster randomized, meaning you'll go to a village or you'll go to a hospital or you'll go to one geography, do one trial there and do the other trial elsewhere. Now remember one thing, and Dr. Sudarshan will talk to you about ethics. Sometimes if you have an intervention or a drug to control hypertension, you want to test it in a randomized control trial, and you say, but my control will be where I will not give the drug. Now, that is a dangerous situation because you're denying treatment to a control group. So, this is where new designs have come, where essentially the control group has to be given what we call the standard of care, which is there for that disease. You cannot withhold that. What you will test will be an intervention over and above that. So there are two types of designs here. One is called a superiority design, where you're testing whether your intervention is superior to the standard of care. The second design that is becoming very popular today, particularly with ethics, is the so-called non-inferiority design. Non-inferiority means you design the statistics in a way that says that when I gave my intervention, it was not inferior to the current state of the art. This is useful when you've got a cheaper drug to give, for example. Then it's really useful if you can show that your cheaper drug is non-inferior to the current state of the art, and people can change the treatment in that way. So these are different designs I'm going through. Now, again, I will tell you, you can forget about everything I've said, okay? Because you can go to this, website called Consort, or also called the Equator Network. Can you please see here, there's something called Consort, CONSORT. Consort is a checklist that allows you to define a clinical trial. If you do a consort and you present your grant proposal following consort guidelines, no one can go against you. No one can criticize you because you have followed the state-of-the-art guidelines. So these guidelines essentially will tell what the steps are in conducting a randomized controlled trial. You have to draw up a protocol. By the way, I hope all of you know what this means, PCOT. PCOT is the way by which you present a hypothesis. It always, that means a hypothesis or a statement includes the patients who will be assessed or the population. I is the intervention, C is the control group, O is the outcomes, and T is the time over which you will do this. So if you have all these terms in your hypothesis statement, then you are clear, or your reviewers are very clear that this person knows what they're talking about because their hypothesis and their protocol has PICOT. Please keep that in mind. Of course, you have to define your reference, and reference means control populations. Please tell the committee how you'll randomize. You must talk to your statistician. It's one way to randomize is to put a bunch of, write 1, 2, 3, 4, 5, 6 on pieces of paper, fold them up, put them into a katori, and then ask the subject or the patient, pick a number. If they pick a piece of paper on which there's number 3, then earlier you would have said all odd numbers will go to the control, all even numbers will go to intervention. That's an easiest way to randomize. But nowadays, statisticians work out randomization in very nice ways, and you should talk to your statistician how you'll randomize. Please define what manipulation, if it's surgical, or what intervention you do, how will you follow up, and how will you assess the outcomes. All this I'm saying, as I said, is there in the consort guidelines. Now, there's one very important, look at this. You can go through this consort for, remember I told you about non-inferiority trials? That's the second one on the left-hand side. Then there's consort for a cluster randomized trial. For those of you who are in Ayush, you will know that there's a consort for herbal approaches. There's a consort for non-pharmaceutical interventions. There's a consort now for what are called pragmatic trials. Please look at this one specifically. This is because the world has realized that it looks like only pharmaceutical companies are able to afford doing a clinical trial. As a result, there has been this movement towards holding what we call pragmatic trials. And pragmatic trials are those where we don't spend too much money and we are able to do, and most academic institutions love to do pragmatic trials. Please look at the consort pragmatic trial. And those of you who are into AI, there's now a consort AI also, which helps you how to define. You will look at AI-based interventions in randomized controlled trials. So if you don't remember anything I've said, I hope you don't remember, because it's more important that you go and discover this for yourself. Please go and look up the consort guidelines. There's one very important graph that you must get in all your grant proposals. You must have this graph in which it will say that this is how I plan to do my study. I will have, based on the expectation that if I go and recruit, say, 10,000 people, only 2,000 will fit my criteria. You have to have these assumptions. So you say, I will assess so many people, I expect so many to meet my criteria, I'll randomize them, I'll allocate so many to intervention, I'll allocate so many to control. How will I follow them up, and how will I do analysis? This is called the consort diagram. And by the way, if you want to publish your trial, you will never be allowed to publish it unless you also provide what they call the consort transparent reporting of trials. It's a consort flow diagram, and you should be prepared to present it in your presentations. Now, for those of you who think that, well, all this is rubbish because I really want to do a diagnostic test research, I'm a biochemist. Well, there are guidelines for how you will actually design a study to test the accuracy of a particular treatment or a diagnostic method. Now, this is called the STARD guidelines. Please go to BMJ. You will be able to, please note this acronym STARD. Please use that. Now, if you look at it, I've been talking to you about guidelines, and I urge you to look at all these. These are the ones you use. The ones I've shown you are the top consort and strobe. However, for those of you who want to go a little further and do systematic reviews, today's journals will never accept a review from you unless you say you followed the PRISMA guidelines. Case reports, you think it's easy to write a case report? Please go and look at the case report guidelines. So can you see this? There's a START guideline. There's a study. There's also a guideline to do animal studies. If you are going to be doing animal studies, particularly in pharmacy work, there's something called the ARRIVE guideline. Please go and look at this. So you can now see there is no reason for you to listen to me at all, because you can go on to Google and ask for the guidelines. It'll tell you. And then in today's ChatGPT world, it'll probably even write it for you. So I'm not saying you should do that. So what are the parts of a good proposal? It is the introduction. You develop your hypothesis. I truly like Dr. Shetty's lecture because he spent a lot of time telling you about what a hypothesis should be. I hope you all listened to that. I certainly did. Please, another important thing that helps your reviewers to understand if you know what you're talking about is if you can give some pilot data, which is over the last year, I've seen this, that, or the other. It would be great if you could do that. Then you go to your objectives, your experimental plan. You must give a statistical power of your study. Talk to your statistician to define the N properly. There are particular terms you use for power of your study. So please go down that path. Please also, it's very important that reviewers like to know if you have thought your study through, that you know what the limitations are. Do you know what the feasibility is? Do you know what the threats are? Do you have a feasibility or alternative plans in case, for example, there was a drought and there was a lot of migration from a particular area and you lost all your subjects? Do you have an alternative plan? So I think all this really gives confidence to your reviewer that you know what you're talking about, and you're writing something that will probably reach a conclusion. That's what your reviewers want. They want that to be sure that this person is not talking out of the blue and will finish the study and has clear ideas as to how to rescue the study, even if it goes sideways. Also give your timeline, because all reviewers like to know at what point would you have achieved what. It also allows the Rajiv Gandhi University to know if you're progressing correctly according to what you had planned. Your research team must include a PI, and it'll be great if you can mention lab personnel and definitely mention your statistician. You must. This is critical. So what do we as grant reviewers look for when we look at a grant? Well, let me start from number 10 going downwards. Research aim is the most important part. Whenever we read a grant proposal, we go straight to the title and the research aim. And if the research aim is poorly written, usually we don't even bother going through the proposal after that. So please write your research aim very carefully. And if you remember what I told you about PICO, the PICOT, make sure all those are there in your aim. Feasibility is the next most important. If you cannot convince your reviewer that you will be able to finish your study in time, that you have the infrastructure and so on, you're not likely to be funded. So please make sure that you convince the reviewer that you can do the study. And this is where pilot data is very important, because it helps to tell the reviewers, this is what I've done. Follow the instructions. Every grant has a format. Now, we have noticed that sometimes people put up grants saying, yeah, I don't care what your format is. I'm just going to write what I want. You won't get your grant. It's as simple as that. You must look at the structure of the grant proposal, fill in the boxes as requested. If you're not sure, contact RGHS and find out what they mean if you're not sure. Please make sure that you define the novelty of your research. And novelty means that you're filling a gap that was not filled before. It's hard, but it helps if you can do a full literature search and then you can discuss this. I always discuss what I do with my colleagues because they have a different view on everything. Place your research in the context of other work that's been done. This is part of your literature background. Make sure that you're extending what is known to what is unknown, which is where what is your research fits in. This is part of the novelty. Without background, you can't define novelty. Make sure that your designs are appropriate to your research. Don't do an RCT where it's not required. It's the most expensive way to do research. Make sure you define your data analysis properly. Again, reviewers will look at this. Make sure, this is really important, that you have sufficient sample size. A proposal without a statistical power statement will not be reviewed well. I can tell you that you probably will not be funded. So interact with your statistician. Make sure that your budget is reasonable, not over budgeted, not under budgeted. So eventually, there's one thing that we always look for. Many grant proposals are not written in a single day. They're written over a month. So when you start out writing your proposal, you'll say one thing. When you end your proposal, your ideas have moved on and you'll say another thing. And then when your reviewers reading it, they say, oh my God, what this person said something here, then they said something here. We call this internal consistency. It's very important that your grant has this internal consistency. And the reason I point this out is because that you will write your grant over a period of time in which your ideas will change. So please make sure that you review your grant for its consistency, for the way it's organized, for the flow, update your references, and so on. So finally, again, let me come back to what I think is the number one thing which immediately gets you to get eyeballs on your grant is, did you write your aim properly? If you wrote it vaguely, you're very likely that you have a jaundiced eye that will be cast on your proposal, because the reviewer will feel, yeah, this person can't even write an aim properly. So when we review, there are clear reasons for rejection. For example, if someone comes aiming to change the world, we say that's overstated, overambitious, unrealistic. Aiming to change the world, not a focused way to do things. We really want focused aims, clearly written. And as I said, if you can put the PICO into that, that would really help. The second reasons where it may be rejected is where we feel that the person has just used ChatGPT to make up a proposal without having any previous proof that they were in that field. So pilot studies, prior publications, these all help a lot in helping you get your grant reviewed. And in today's world of ChatGPT, believe me, without pilot data, it's very hard for a reviewer to think, did this person make this all up? Or is this something they've been thinking about for some time? Your methods should be well developed. Sometimes you get research done, proposals where the outcome is so poorly described that you just reject it immediately. And they don't describe their statistical methods. There's no way. Finally, remember that a reviewer is going to do this squeezing time out of their busy schedules. If they see a grant that is poorly laid out, does not follow the instructions, is difficult to read, just uses terms and is inconsistent, as it is, they're irritated. It's hard to find a reviewer who opens a grant review in a good mood. Usually they're like, oh God, I have to finish this work. Let me do it. They're already irritated before they even start. So it's good to make sure that you present something very well to them. So, in summary, good science and clear scientific writing is critical, really important. And if all eyes, you don't need to remember anything, just go back to Strobe, go back to Consort, go back to all the other checklists that are there. You will be able to write this very well. Make sure that you're organized well and that when I say self-contained, it means that your grant proposal ticks all the boxes. It should be responsive to the request for applications. It should not be something else other than what they requested for. And really, if you can clearly tell your reviewer that this has a potential to advance the field, you really are in a very good place. I'll stop there. Thank you. Dr. Shetty, I've finished. Are there any questions? I'm happy to take any questions. I can't see anyone. Dr.
Hi.
Suja,
Yeah.
Suja has come. Dr. Suja, can you hear me?
Hi, Dr. Anura. Can you hear me?
Yes, sir.
Yes, I can hear you.
Yes, sir. Yes, sir. Hello, Andra, sir.
Yes.
So, good morning, sir. Yeah, I can hear you, sir. You can continue the session.
Yeah, so there's someone with a question, I suspect.
Yeah. Hi here. So myself, Dr. Venkatesh from Abaipur, a pharmacy institution in Bangalore. So I have a question. Very nice talk from your side, sir.
Thank you.
I'm into preclinical research. As you mentioned, there is also various arrive guidelines for the preclinical research, especially animal studies. Also for other fields where in the clinical research there are going to be clinical formulations which are going to be useful in conducting the studies. Are there any such guidelines where the standards for the formulations which are prescribed for the manufacturing or any of those which you normally see that those qualify those conditions prior to initiation of the trials?
No, I'm not aware of any guidelines for formulation, which I think would be very useful actually. Yeah, I'll have to just check on this, but I don't know of this. But typically, once the formulation is made, the critical guidelines, I think you have to get DCGI. I'm not sure if you're going to test on patients, you will need DCGI approvals and then ethical approvals. These are two approvals that you typically require. And I don't think they go by guidelines as much as they go by concerns about toxicity. As much as so efficacy is something you are trying to prove in your combinations, but toxicity is what they'll be concerned by. And I don't know if there are guidelines for that. I'm sorry, but you can look at the CDSCO, yes, or you can talk to Dr. Sudarshan, who will be talking soon on ethics. He's a trove of information on the guidelines for doing research.
Sure. Thank you.
Sorry, I can't.
Nice talk. Yeah. Otherwise, nice talk. Very, very informative. Thank you.
Thank you. Dr. Suja, madam, may I stop here, or I think I can't hear you. You're muted. Dr. Suja, you're muted.
Sir, there is problem in the RGHS.
No, sir. Absolutely, there is no problem in RGHS. I had not unmuted. So thank you very much, sir. Anurag Tripathi, sir, for the wonderful session. Thank you, sir.
Thank you.
Next, we'll be having the session of Dr. Rajesh Anai, sir, who will be speaking on writing a research proposal to RGHS and the process of evaluation. Welcome you, sir. Rajesh Anai, sir. Now over to our director, Dr. Ramchandra Shetty, sir.
Let him come. You have to take it. Sir, Rajesh Chennai, sir, you are there?
Yes, sir. Good afternoon. Can you hear me?
Please, you share your slides and please go ahead with.
Sharing is not permitted so far. It is disabled.
Permita, you need Kirti. Sir, we will do it, sir. You are there in Zoom, you know?
Yeah, I'm in the Zoom, sir.
Okay, sir. Shortly will be. AC meeting is going on. There was a question question for the R&D department. That's why I moved there. Sorry for that. AC meeting and syndicate meetings are going on today also.
Oh, 2 meetings are there.
3 meetings, including this. That's why we see. Hey, Kirti, share model permission kodapa Chennai sarge. One then Beka koda is there already. Please. Hello.
Or shall I share the presentation to you and you can put it up there?
Yes, sir. You can share now, sir.
Okay, let me try 1 minute.
No, I think permission is given right now. You can share now.
It is not coming, sir. Still disabled.
1 minute. I will be attending, sir. Because it is linked with YouTube, ಅದಕ್ಕೆ ಅಲ್ಲಿಂದನೇ ಕೊಡ್ಬೇಕು. ಈಗ ನೋಡಿ ಸರ್ ಬಂತ ಶಣೈ ಸರ್.
Sir, I got it.
Please share it, sir.
Can you see it, sir? Screen is visible?
Yes, sir, it is visible, but now it is again shared screen on, and now it is visible, sir. Sir, ನೀವು ಇದು ಮಾಡಿ ಸರ್ ಅದನ್ನ full slide show ಮಾಡಿ. Yes, sir. It is clear, sir, now.
Okay. Good afternoon, everybody.
Okay.
I thank RGHS for giving me an opportunity for presenting this presentation for the research methodology workshop. Most of the topics what Dr. Anura has told and what I will be talking, most of them overlap. But I will be going into the more of the tech part of it, technical details. So let's start off. Basically, crafting winning research proposals for RGOHS. So the major truth, what everybody wants to know when you apply for RGOHS is 60% of the proposals get rejected. The basic reason for these rejections are unclear objectives, weak rationale, poor methodology. So we should know how to write it in the right way so that all our proposals get accepted actually. So what exactly is a research proposal? This is basically to think as a, what I can tell is a marriage proposal, but to RGHS you're asking, I have a great idea, please invest in me. The committee must say yes before even you start. That should be the way how your proposal should be put up. So there are 4 parts in this. Basically, one is the problem, one is rationale, one is methodology, and next one is the impact. So these are the 4 important points which you need to note. So how a research proposal should be there? You should have a specific title, which should be very specific and concise, followed by a research objective question, research question and objectives. What it has been discussed already is SMART, it has been told to you. Next is the methodology, how you are going to do it. What is the method you are going to follow? Introduction is required, review of literature as spoken by Dr. Anurag, which is required, but try to keep latest last 5 years. These are important literatures. And budget and timeline, this is very crucial because these proposals should adhere to the timeline what is given by RGOHS. So again, I come back what Dr. Anurag has told. One is the qualitative, and one is the qualitative research, and one is for the quantitative. So basically, for quantitative, you can keep PICO in mind: population, intervention, comparison, and outcome. Whereas for qualitative, SPIDER, you can keep it in mind: sample, phenomena, design, evaluation, and research type. So these are important things. Specifically for Ayush, basically there will be a little bit difference when you compare with other faculty of healthcare subjects. So Ayush has to be a little bit different. I have given an example also how it works for Ayush, Yoga, or Unani. You can still work it out, and RGHS accepts research proposal for all subject specialties. So these are the faculty which we are looking into: medicine, dentistry, pharmacy, Ayush, nursing, and allied. So these are the this is just a topic what I am thinking or what you can start working on. Basically, these are the just brief ideas what I'm giving you. There may be other subjects also. And one more good way to start off with is check what were the research projects which have been sanctioned previous year, so that you will exactly know where is the focus, where the research advisory committee focuses on spending the money for research. So how do you go about these research proposals? There are a lot of resources which are available for you. As usual, you know Helinet, which is available in RGHS, which is a gateway to the lot of journals. Then there is a Skyspace, which is an AI-powered platform. You have PubMed Central, Scholarcy is there, TCS is there, which will find the gaps between your study. And Chat PDF, you can upload any RGHS guidelines and ask the plain questions, it will reply to. So maybe you should start with Helinet, then go to PubMed, Skyspace, you will cover 90% of whatever you need or you're looking for in 2 hours. So there is AI available now. Nowadays, everybody uses AI. But one thing you have to keep in mind is AI should be your servant, not you should be AI's servant. So whatever the AI tells, you should have the capacity to verify it is right or wrong. So you can use ChatGPT, Claude, Review My Paper, Grammarly, Writewise. Then AI ethics guardrails for RGHS proposals can be shown. Then you can have a sample AI prompt also, how to review these papers. So check into the previous sanctions been done, which have been approved. All data is available online. Go through this. The process, how it runs is basically what happens when you submit a proposal to RGHS. There is a call for which is made by RGHS, a deadline is given, we select a topic and go according to the research proposal. Again, I am coming to certain topics which have been discussed by Dr. Anurag. Methodology which makes the reviewers nod. Basically, you have to catch the attentions of the reviewers. So how the review process happens in RGHS is, once you submit the proposal, it is scrutinized in-house whether it is suitable to be taken up. Once it is approved, then it is sent to the in-house faculty who will scrutinize, a subject specialist who will scrutinize it. Again, it will be sent to an external agency for scrutinization. Based on the scores of both, it is selected to be presented before the review committee. Review committee will go through the presentation, which will be done in person. And based on the feedback from the research committee, the grants are decided. So these are the sample sizes, how you can calculate, choose the right designs. These are all basically technical details. You can have different kinds of study, RCT, cross-sectional, case control, cohort, quasi-experimental or qualitative. Basically what happens is, I have seen basically sitting on these research committees, a lot of people come with the sample size according to their whims and fancies. There is no justification for why you have selected that particular number. So we need a justification. So for that, please do a proper homework and come out with the exact number of samples or sample size required for the study. So as I told you earlier, this is how the review process goes on, how the RGHS reviews the proposal. So once you get the decision from RGHS, the reviewer score I have just put it X. This is approximately how it happens. These are not the exact guidelines, but approximately this is the way how the committee reviews these proposals. So once your proposal is approved, the next step will be for you to open a bank account for the university to transfer the funds. This bank account should be in the name of the institutional head, whoever is the principal or dean of the institution, and the funds will be transferred to this account upon final decision by the review committee and the agreed terms and conditions for the payment as per the committee's decision. So why proposals get rejected? As it has been told earlier also, objectives are not specific, literature review is not latest, you may have done old ones, no mention of ethics or informed consent. This is one of the biggest problems. A lot of people apply for the research project and then they will tell research committee is still not met, we are waiting for the documents. It will usually be rejected. So please ensure that when you come for a personal presentation, all papers are in order. Then next is the budget with no justification. A lot of people budget without keeping in the final points what the research proposal application says. Basically, RGHS doesn't fund for equipments or basic infrastructure what is required. Only the reagents, kits or whatever is required only for that research is sanctioned. So please keep that in mind. We don't fund for software, equipments or anything like that. Then PI should have a relevant publication experience. You should have a basic number of publications which are happening, and the paper what you have presented, proposal what you have given should be in line with the expertise what you have. An institution can have a PI and a co-PI. In case if there is a outside technical support required, then you can have a co-PI from outside institution, provided it is not available in the parent institution. And the last but not least, you need to have a very novelty in your research project, otherwise it will not be accepted. So whenever you keep up the project, please ensure that there is something novel in this research project. So rest again, it will be a repetition which I don't want to do it. So please go through it. Now coming to the budget planning and ethics, these are the two deal breakers basically. You have to ensure that the research assistant fees, whatever is there, usually it is nominal, it is not for giving employment for somebody. Somebody in your institution can be given additional work and A nominal amount may be given. Consumables will be funded by the university, but again, the rates should be quoted as per the market rates. Equipments, and usually we don't fund it. Please don't go for that. Travel, field visit, sample collection, if permitted as per the committee decision, will be permissible. Publication, whenever there is a offer for publication, and if there is some fees to be paid for it, please revert back to us. We can help you out with this. Ethical clearance, as I have said, there are a lot of different kinds of clearances required for different kinds of projects. So please go into those details and ensure that you have proper ethical clearances for the research project, whatever you are presenting. And you should also keep in mind that the patient data should be anonymized and no specific patient details should be made or mentioned in the proposals. And also keep in mind that the research committee will be up to date with the market rates of the tests or kits or whatever is given. So don't think that whatever you quote will be sanctioned. So these are various AI proposals workflow which you can use for doing your project. It is not like before. Now, because of the advancement in technology, you can use all these platforms which can help you to come out with a professional research project which can be submitted. Only point is you need to know what is right and what is wrong, because if there is something wrong information which is being given by the AI platform, you should be able to analyze and pick it up and remove that. So they use all these AI platforms. You can use it for doing a faster work and applying for the research project in a better way. So these are the AI tools at a glance. As I have told you, literature, you can look. AI writing, there are different platforms which are available. Sample size, there again, compliances, again, it is available. All these, there is no need of anybody who need to go and ask also. All the guidelines, specific mentions are available there, and most of them are free, except for a very few where you need to pay. So as I said earlier, for a winning proposal, these are the things what you need. First is be problem. Start with the patient or community gap, not your passion for something which you think that it is very near to you're interested in. Be specific. Always you have to be very specific. Vague sentences will never get your proposals accepted. As far as possible, use all the free tools which are available and come out with a very professional research proposal. Let AI edit, but not the author. That is what I told you. You should be able to differentiate now. Understand the reviewer, the committee, who sits in the committee, what the questions they ask. Please think about it and plan accordingly and come forward. Best proposal is not always the cleverest, it is the clearest. Please look into it. So one more point is, once after your project is sanctioned, the process, what happens is, you will be granted funds initially as per the installments which have been agreed. And upon submission, means once you have consumed that whatever is there as per the timeline given by you, based on that, you need to send a audited statement which has been approved by an auditor to the university. And if required, university will also send a team for verifying it. And once the initial statement is accepted, the second round of funds will be allocated. Till then, it will not be allocated. In case if a PI leaves in between for some reason, the co-PI is permitted to take over, subject to the condition that he has an expertise in that and he has worked on the project. I have covered almost all the topics what are required. If you have any doubts, please ask.
Sir, namaste. In continuation with Chennai sir's talk, I have one point to stress upon here regarding budget. You see, last time or in my experience as a research committee director, I found that many of the people are not writing realistic budget. Some people write exuberant, some other people will be writing undercosting. So that is not good. Always please pre-prepared for realistic budget. This is one thing. And now I thank Dr. Shanai for his wonderful lecture on the proposals that are to be prepared for submitting it to the RGHS. Thank you once again, sir.
Sir, I will share
And-
the PPT also in case if somebody wants, because there are links to those AI tools, you can use them. Thank you, sir.
Okay.
Thank you for
And
giving me the opportunity.
before we break for lunch, if there are any queries regarding this, please put up your queries. And after the lunch, we have got small change. In our timetable, we mentioned that Lancy D'Souza on statistics will speak at 3:30, but is reversed. Sudarshan sir will be talking last, and before that,
Sudarshan sir will talk first.
Sudarshan sir will talk first, and biostatistics will be the last talk. And I request you to cope up with the changed timetable. Now we shall break for the lunch. After the lunch, exactly at 2:30, we shall join. And for you people who have joined on YouTube, we will be sending new YouTube link. Please go join through the YouTube new link only. And thank you, sir. For the people who are on Zoom, they can join with the same link. Thank you, sir. ಇದು ಹಿಂಗೆ ಇರಲಿ ಬಿಡ್ರಿ ನಮ್ದು ಯಾಕಂದ್ರೆ ಆಮೇಲೆ